phase locked loop, block diagram, operation of PLL. It is a technique for electronic frequency control. It is mainly useful in satellite communication systems, airborne navigational systems, FM communication systems, computers, etc. So this is the basic block diagram of PLL. You have input signal frequency Fs, signal voltage Vs, phase detector, low pass filter, amplifier, VCO, voltage control oscillator. Output of VCO is V0 with the frequency F0. It consists of a phase detector or comparator, a low pass filter, an error amplifier, a voltage controlled oscillator. The VCO is a free running multivibrator, operates at a set frequency F0 called free running frequency. External timing capacitor, external resistor determine this frequency. It can be shifted to either side by a DC control voltage Vc. Frequency deviation is directly proportional to control voltage. Hence it is called voltage controlled oscillator or VCO. If an input signal Vs of frequency Fs is applied to the PLL, the phase detector compares the phase and frequency of the incoming signal to that of the output V0 of the VCO. If the two signals differ in frequency and or phase, an error voltage VE is generated. The phase detector is basically a multiplier and produces the sum Fs plus F0 and difference Fs minus F0 components at its output. The high frequency component Fs plus F0 is removed by the low pass filter, and the difference frequency component is amplified and then applied as control voltage Vc to VCO. The signal Vc shifts the VCO frequency in a direction to reduce the frequency difference between Fs and F0. Once this action starts, we say that the signal is in the capture range. The VCO continues to change frequency till its output frequency is exactly the same as the signal input frequency. The circuit is then said to be locked. Once locked, the output frequency F0 of VCO is identical to Fs except for a finite phase difference phi. This phase difference phi generates a corrective control voltage Vc to shift the VCO frequency from F0 to Fs and thereby maintain the lock. Once locked, PLL tracks the frequency changes of the input signal. Thus, a PLL goes through three stages: free running, capture, and locked or tracking. Lock-in range, the range of frequencies over which the PLL can maintain lock with the incoming signal is called the lock-in range or tracking range. Capture range, the range of frequencies over which the PLL can acquire lock with an input signal is called the capture range. Pull-in time, the total time taken by the PLL to establish lock is called pull-in time. Phase detector, comparator. There are two types of phase detectors used, analog and digital. Analog phase detector. So this is the schematic. An electronic switch X is opened and closed by a signal coming from VCO, which is normally a square wave. The input signal is chopped at a repetition rate determined by VCO frequency. These are all the various waveforms related to that. The switch X is closed only when VCO output is positive, and the output waveform will be half sinusoids. This type of phase detector is called a half-wave phase detector. Analysis. A phase comparator is basically a multiplier which multiplies the input signal Vs equal to Vs sine 2 pi Fst by the VCO signal V0 equal to V0 sine of 2 pi F0 t plus phi. Thus, the phase comparator output is V equal to K Vs V0 sine of 2 pi Fst into sine of 2 pi F0 t plus phi, where K is the phase comparator gain or attenuation constant, and phi is the phase shift between the input signal and the VCO output. The above equation can be simplified as V equal to K Vs V0 divided by 2 of cos of 2 pi Fst minus 2 pi F0 t minus phi minus cos of 2 pi Fst plus 2 pi F0 t plus phi. When at log, that is Fs equal to F0, if you substitute that, then V equal to K Vs V0 divided by 2 cos of minus phi minus cos of 2 phi into 2 F0 t plus phi. The double frequency term is eliminated by the low pass filter, and the DC signal is applied to the modulating input terminal of a VCO. So these are all the corresponding waveforms. Next we have digital phase detector. Digital type XR phase detector. It uses CMOS type 4070 quad to input XR gate. This type of detector is used when both the input signals are square waves. Phi is shown in figure. It can be seen that the maximum DC output voltage occurs when the phase difference is pi. The slope of the curve gives the conversion ratio Km of the phase detector. Another type of digital phase detector is an edge-triggered phase detector, whose schematic is this. This circuit is useful when Fs and F0 are both pulse waveforms with a duty cycle less than 50%.